Let's walk through an example of clustering and anomaly detection. The code is available in the text. It's basically copied from the chapter. I've added a few things to explore it a little bit more here, and there's a link to the data set that I'll be using as well. This data set comes from companies and it has three different industries with different levels of profit margin, asset turnover, and leverage. So first we'll read in this data set that we're going to be using the tidyverse and H2O. So we'll read that in. It appears here at the top right. Just to get an idea of what the data set looks like, let's plot a histogram of asset turnover. And you can see there are some large outliers here. Most of it is clustered a little bit lower, and there's a bunch that is very near zero. Uh, you could plot other things as well. Those aren't as critical, so we're not going to work on them right now, but you could plot other things. In the chapter, I give two functions. This Windsor's function is to take extreme values and move them in a little bit. This is making them 98th and the second percentile the cutoffs, and so it'll move anything beyond those in a little bit. Standardizing is just to center and make the standard deviations the same. So that's what I'm doing here. So I'm using the data frame that is on the top right here, DF, moving it over into data frame 2, and I'm going to apply the Windsor's and the standardize function to the three columns. Once I do this, I can look at a histogram of these. Oh, whoops, I didn't create the DF2. Oh, I think I didn't do these either. That was part of the problem. Okay, so now I have DF2 up here. Now I can look at the graph. Notice it goes below zero now. There's still the big chunk at the bottom, and the outliers aren't as extreme. So for us to understand how these industries differ, there is an industry code in the data frame. So if I go here, IND is the 3-digit SIC code. And just for you to see how these industries differ, let's summarize by each industry or each industry's variables. And so here we see 527 has the lowest asset turnover. These are standardized now, so they have positive and negative values. This just means relative to the mean. So the lowest relative to the mean is 619, then 527, then 736. So 736 has the highest asset turnover. 619 has the highest profit margin. Leverage is highest in 527. So we will refer to these in a little bit, but they're different enough that we might think we could separate them with our techniques. The reason you might cluster, uh, this would be assuming we don't have the industry and we just want to see how companies are similar. We're using known industry so we can evaluate how well it works. In practice, you would try different things and hope you get close if you don't have an observable thing to work with. Okay, we're going to initiate the H2O instance. If it says it is successful, then we can do it. And we need to move the data frame over into H2O. So we're going to select only the columns that we're working with. We're going to make this an H2O data frame, and we're going to save that as temp.h2o. So now it'll show up as an object over here, even though we can't access it because it's in a separate environment. This is the setup for doing k-means clustering. Here we're going to use 3. That's because we know that there are 3 clusters. If you don't know that there are 3 clusters, you might try different numbers of clusters. Sometimes you'll know, sometimes you won't. Most often, probably you won't. So you would try different levels and see how well it works. Let's estimate this and then see the output. So just putting Km is doing the output so we can see what comes out of it. And it tells us a little bit about it. So how well does it fit? This is, these are the errors in it. So same thing as these. The first cluster fits the data the worst. The second cluster fits the data the best. Um, and there are three clusters. Well, we told it there are three clusters, but um, that's what it found. And then the first cluster has just over 1,000 observations. The other two have a lot fewer observations. And let's see what those clusters look like. So what this does is, as it's randomly assorted observations into these groups, now it tries to separate them, and the centers are the means for each of those groups. So we see here that asset turnover for the first group is the middle group. Asset turnover for the second group is the lowest. Oh, sorry. The asset turnover for the first group is the highest. Asset turnover for the second group is the lowest, and the third group is in between. For profit margin, the second group is the highest, the others are lower than that. And for leverage, the third group is the highest and the others are lower. So we do have some separation. If you recall from the means from the industries, it might align a little bit with those industries, but as you'll see, it's not exactly the same, but it's done something to separate them. If we want to get what groups each observation is in, we use this predict function to take these where they're assigned and put it back in the data frame. So predict, what it's doing is predicting which group they're in. And then once we have this, we're making it a data frame and pulling out the prediction column. And we're going to assign this to the same df2 that we were using and call that column cluster. So if I run this, open up here, you see we have a new cluster column here. It goes from 0 to 2, so 3 groups. And let's look and see sort of what that looks like. Uh, 0 is the first group. The first group is the largest, has something like 1,000 observations. So let's start with 2, which is a smaller group. And 2, it looks like we have a lot of the industry 619 here. So let's keep looking down. So mostly we have industry 619. So maybe it was successful in getting 619 as a separate industry, but notice we have some others that get in here, 736 and 527, a few others of 736, well, several of those, and then we're back to 619. So it did a pretty good job lining up with the industry classifications. We get to the next group, 1, we have 619. That now we have a second group that looks sort of similar. So it didn't do a good job separating them out here. And then we get to the first group, the group 0, and it looks like we have lots of 736 in here with a handful of others that are from the other groups. So it did a pretty good job of separating out 736 from 619. The other group kind of got mixed in with the others. Well, I'm not going to scroll across one just by chance here, but it did a pretty good job. Not quite identifying cleanly which industry they were in, but it does a decent job of getting some separation there. If you had more data, then you might be able to plug in more and get cleaner separations, but it at least gets us closer. All right, so then let's say we have these clusters, we're sort of okay with them. Anomaly detection then says ones that group together are different from ones that sort of don't fit these groups. And so what the different versions of anomaly detection try to find ones that don't fit in the group. So we'll use this extended isolation forest here. One of the benefits is it's quick, and it's more flexible than the like using k-means to find them. So let's try that. So we use the same data frame. We use extended isolation forest, and there isn't as much to see from it. So we could put that in here, and it tells you um, here are some points about it. So it did this model. It used some technical things here, which we'll talk about later, and gives some ideas of what the anomaly score looks like. So it isn't really too interpretable yet. So what we're going to do is take the scores where it says some observations are more unusual than others. So we're going to use the same predict thing to get it out of the model into the data frame. So we're going to create the anomaly score, and the same thing. We're going to move it into the same. So this is all create a data frame, pull that column, and put it in the data frame we were using. So if I run this, now this column is going to be in that data frame. So next to cluster, now we have this anomaly score, and let's look and see sort of what that looks like. The highest score are the ones that it thinks are the most anomalous, and let's see if that seems to be the case. So we can go back to where we had these centers. Of course, we could compare with the industry too, but it found things like these centers. So let's see um, if it seems to work here. So the most unusual it finds is profit margin minus 20. So it fits it in this first group here. It's about that same amount. So far, not too unusual. Asset turnover of 90. Well, that doesn't fit this group anymore, right? So it's actually higher than all of these centers. And if it is it within this profit margin group, it's high, even higher there. So that seems to make sense. It was on asset turnover. And then leverage 4, it's higher than all of these groups and especially higher than this group. So that seemed to do what we would expect. The levels don't match up really with a single one of these groups. Let's try one of the next ones just to see. So we've got a bunch of these with low profit margins. Let's try this one here. High profit margin. That would put it in this group 2. So far it's a little high. Could be that, but not too unusual. Then we have asset turnover that's low. That also is in this group here. Leverage 0.28. That is very different from the negative. So we have higher leverage than this group and higher profit margin. So again, that seems to say that it is different from the group that it is put in, or that it might look like. Okay, so then once you have these, you might then use this data frame. Sorry, I should have left it open. And think about these clusters. Now you have groups that you can put observations into, and you have observations that are more unusual than the groups that it can find.